Hello, I hope you are fine. I am Hamid Arbay. I will present today a session on Service Fabric and Microservices. This session is in English and you can find another session in French presented yesterday about the same topic. What you will learn today, the basic of Service Fabric, local deployment and remotely in the cloud using Azure. I am Microsoft MVP in Developer Technologies, architect. If you have any questions during this presentation, you can use the chat option on the right here. I will answer you immediately. If you want to join me, this is my email, or you can follow me on Twitter. We will talk at the beginning about the advantages of microservices compared to monolithic application, then an environment preparation in order to start the Service Fabric demo. In a changing market, one of the main challenges of maintaining the competitiveness of digital business remains IT agility. However, in their current state, computer systems are struggling to adapt to the latest technological developments such as mobility, Internet of Things, and to their new requirements. With a large number of dependencies of services linked to the life cycle of an IT project, each modification of the source code inside the classic monolithic application can destabilize all functions related in maintenance. For these reasons, companies have resorted to more optimized, scalable architecture, ensuring continuous availability and less constantly in terms of research conception and in particular oriented microservices. This change is essential, facing the aggressive competition, and in particular that of startups which are not yet congested by rigid infrastructure. Before talking about microservices, we need to understand the difference between the traditional application approach and the microservices application approach. Any application is built as a collection of services can be developed, tested, versioned, deployed, and scaled. For a monolithic application, scale is done by cloning the application on multiple server or virtual machines. But for microservices, scale is done by deploying each independently with multiple instances across server or virtual machine. I highly recommend seeing more details about microservices on this website of Martin Fowler. Microservices are very similar to beehives. Within a hive, thousands of bees coexist and help each other for a single common goal, the survival of the colony. The queen, the worker, and the drones each have their peculiarity and must therefore assume very distinct tasks. So everyone have specific tasks according to the hive. When developing a server-side application, you can start it with a modular, hexagonal, or layered architecture, which consists of different types of components or layers. We start by presentation layer, that is UI layer. Here it can be a web or mobile or desktop application. We have the service layer here. It's responsible for handling HTTP requests and responding with either HTML or JSON or XML. And here we talk about a web API too, for example, or web services. We have the business logic layer, the database access layer that's responsible of accessing to the database here. As we can see, in monolithic database are shared across services. So from here to here. Despite having a logical modular architecture, the application is packaged and deployed as a monolith. Monolithic applications are most of a single complete package, having all the related needed components and services encapsulated in one package. But for microservices, the idea is simple. It consists to split your application into a set of smaller interconnected services instead of building a single monolithic application. This is one first server, this is the second services here, and the API gateway ensures the communication between the web part, the desktop part. Here we have the presentation layer. Each microservice is a small application that has its own hexagonal architecture consisting of business logic along with various adapters. Some microservices would expose a REST API, RPC, or message-based API, and most services consume APIs provided by other services. Here we understand why we have the API gateway to manage that. Other microservices might implement a web UI. Microservices are deployed independently with their own database per services, so the underlining. So as you can see in our image here, microservices allow us to scale, deploy parts of application independently. They offer great distributed software challenges. But with these benefits, we cannot always choose microservices because they are intended for large, scalable, and long-term distributed application. Do not underestimate the complexity in implementation and testing. We will now present the different architecture and pattern of microservices. And in this table, we summarize the modern patterns and technology to be used, like containers. We have containers here. Containers. There are many models, and patterns. Most of them are linked to the domain-driven design. We can find here CQRS, the events, and our API gateway that manage the communication between microservices. We have Docker here container, Linux container, Docker image, so we can find orchestrator, and we have here Azure Service Fabric, and we will talk about that today in our session. Companies face challenges in their passage to the cloud because, for example, there is an optimization of the development of microservices to be taken into account. Similarly, achieving reliability, consistency of state and data without latency problems. We have monitoring and governance at overreaching and granular level, and we have more and more challenges before and inside building cloud application, before and after moving to the cloud. In Microsoft Azure, we can find a complete set of choices here. We can find many platform as a services. For example, we have app services. Here we talk about Service Fabric. This is our session. Kubernetes services, it's the orchestrator, container instance, and batches. There are 3 major services in Azure. Let's start by Service Fabric, which we will see in more detail during our session. It supports microservices developed by any language, and the Service Fabric Mesh offers more features and intelligence in routing. We have also Azure Kubernetes, that is a container orchestrator containing microservices, easy to manage. And finally, we have Azure Function, where the function is a part of services that it will be triggered using a trigger. Service Fabric allows you to create, manage, scalable, and reliable application composed of microservices. These distributed microservices run at very high density on a shared pool of virtual machine, which correspond to a cluster. Service Fabric provides a lightweight and sophisticated runtime that supports stateless and stateful microservices. It also provides full application management functionality for configuration, deploying, analyzing, upgrading, patching, and removing application. Service Fabric presents the next generation platform for building and managing these cloud-level tier-first enterprise application running in containers and works with other providers such as AWS, Amazon, and OpenStack. Azure Service Fabric is a distributed system platform that facilitates the packaging, deployment, and managing of scalable and reliable container and microservices. Service Fabric also solves the significant problems of deploying and managing native cloud applications. Developer and administrator are able to avoid complex infrastructure issues and can focus on implementing strategic and demanding workloads that are scalable, reliable, and easy to manage. Service Fabric can be running anywhere. You can create clusters for Service Fabric in many environments, including Azure, local, or my Windows Server, or on Linux, or in another provider, as we said before, AWS or OpenStack. You can even create clusters on other public clouds. In addition, the development environment in the SDK is identical to the production environment, with no emulator involved. In other words, what runs on a local development cluster is deployed to the cluster in other environments. And here we can see what Azure Service Fabric can offer for us to bring the infrastructure. Here we talk about Service Fabric standalone. Here we talk about clustering, Service Fabric dedicated to Azure clusters, and we have more options in routing, and we talk about Azure Service Fabric Mesh used for serverless microservices too. And here we can find what's our responsibility and what's the responsibility of Azure here virtual machine, the cluster, app deployment. So here we can choose between one of these options. The Service Fabric is an open source project and is used in many Azure infrastructure services as well as other microservices, Microsoft services, including Azure Event Hub, Azure Cosmos DB, Azure SQL Database, Dynamics, Cortana. The main subsection of Service Fabric can be seen below. Here we can find Visual Studio, Team Services, TFS, Event Grid. Service Fabric provides lifetime management capability for microservice-based application. Microservices are hosted in containers that are deployed on the Service Fabric cluster. The use of container instead of virtual machine means a massive increase in density, and an even greater density can be achieved by switching from containers to microservices in these containers. Let's take an example. A single cluster for Azure SQL database is made up of hundreds of machines running tens of thousands of containers, which in turn host hundreds of thousands of databases. Each database is a microservices with Service Fabric status. So in this diagram, we have the Service Fabric architecture. Each layer has a specific role. Let's start from the bottom here. The transport subsystem is responsible for providing secure communication channels between the nodes of a Service Fabric cluster. The above federation subsystem allows you to logically group physical or virtual nodes in a cluster so that it can be managed as a unit. This helps Service Fabric to perform tasks such as troubleshooting, electing leaders, and routing. The transport subsystem provides a communication channel for intra and inter-cluster communication. The federation system here is responsible for the logical grouping of virtual or physical machines to form a Service Fabric cluster. This subsystem uses the communication infrastructure provided by the transport subsystem to achieve this consolidation. For more detail about the other parts, you can see the official documentation of Microsoft. Now we will go through practical. Before we start, we must meet this prerequisite in order to be able to configure our Windows development environment to create and deploy locally Service Fabric. So we need Windows 10. It's really required professional edition to be able to install Docker. This is requested when we start working in the end with the containers. We need Visual Studio 2019 or 2017 has built-in support for Docker. This is important. I will use the last version of Visual Studio. .NET Core SDK, Microsoft Service Fabric. This we will see how we find the link after. I will show you how we can install the SDK. Docker for Windows and Docker tools. This is optional, but it will be required when we try to build a container and deploy it in Service Fabric. Let's set up now our Windows development. We will start by installing Visual Studio 2019. So this is the link. You can find the latest version here in this link. We have community, professional, enterprise, community. You can use the community version. It's free. And here we can find the link of Microsoft Azure Service Fabric SDK for Visual Studio 2019 and 2017. And you can find more in the button, more links if you have another version of Visual Studio. So here, Visual Studio is installed. And if you need all the SDK, you can find the link in the bottom. You can install this package. Now, the SDK is installed. You can find here the web platform installer. We need only to add this one. The other one is related to mesh. It's in preview. So just we accept and we wait a few minutes. So here it's finished. Now let's move to Visual Studio to create a new project, new service fabric. So here we create a new project, we open Visual Studio, we will try to write the search for fabric. It's really easy to find the template service fabric application here. So the description in the bottom. So we click here in C# in our case. We give a name, location, we choose the framework, we fill what we have here. So I will choose the latest framework. After we go to the next part, click. Now, as you can see here, you have many choices. We have stateful or stateless. We have services and application. We have containers, .NET Core framework, or .NET framework. So here I will choose stateless. We don't need to use another option, but we choose stateless services. We create. Here, as you can see, now we set up a local service fabric cluster. So, service fabric cluster, we go here to the manager of the cluster. We need to execute it as administrator, to run it as an administrator, and as you can see here at the bottom, the icon, we have to start the manager before. You can reset the manager, and we can manage our clusters with the web application that will be launched locally. So here we click on Manage Local Cluster to be able to see what this includes. Here we can define our node 1, 5. I choose 5 for me to show you just how we can. So here we have the Service Fabric Explorer. As you can see, we have the nodes, we have the no application because we didn't deploy any application or compile any application. Status is green, so it's okay. So our environment, the environment is okay. So when we click to manage, we get the Service Fabric Explorer. Here we will deploy all our clusters. Now we create a service fabric using Visual Studio as before. So we say we use the same thing, we create a new project, we try to find the template of fabric, and we will choose stateless. During this session, our demo will be for stateless, not for stateful. So I will fill our information requested here. Last framework, service, I will choose the first one. And we wait a few seconds. So when we click on start, we verify if our application is running. And when we click on start, as you can see here, everything is okay because we get this panel, diagnostics, we have the workers. So everything is working very well. And here we are in phase 2, create an image temporary in our service fabric. We will find our application, as you can see here, running in its environments. Here, our application, you can see the name here. Now, here, more details about the application. If we have any problems, we can check the healthcare monitoring. All part of monitoring are here in Service Fabric Explorer. Now we go back to our application to discover more. So this is our application. Here we can find in the configuration file, we have two files, one for node 1 or node 5. In our case, we used 5 nodes, so we will use the second one when we try to publish this application. Here, as you can see, no application. Only we have 5 nodes, so the configuration related to 5 nodes are there. So we have to publish the application to be running always in Service Fabric. When we compile and start the application, we have the environments ready. Now we will publish locally. So we click on publish. We choose here, the first one is to publish to the cloud. We have 1 node, 5 node. In our case, it's 5 nodes. Here we have local cluster, and we get this one. We choose 5 nodes, and we click on publish. Now our application will be hosted as Service Fabric cluster in Service Fabric cluster, so we can see that in the Azure Fabric Explorer, Service Fabric Explorer. Here, Service Fabric Explorer. Now we need to refresh. Sometimes we get some problems, and we can check these problems in this place. So we did the monitoring here. Now, so we don't need to click to start because it's published. So as you can see here. Now we will build .NET Service Fabric application. We will close this solution before. I will show you how you can create a .NET application, the different options that we have. After, we will try to clone from GitHub an example presented by Microsoft to try testing Service Fabric. So let's start here in the same way. So the same templates of Service Fabric application. And this time we will choose .NET Core, for example, .NET Core application, and you will see here, we'll check, yes, it's this one. And we will try to see what we have here. Here we have the API. We can create a web application, MVC, Angular, React.js, so all templates. So we choose MVC in our case, but we can find all web application the same that we will use it to create any .NET application core. During this session, this part for publishing .NET Core, we will try to copy and paste the code from documentation of Microsoft, just to show you that's really easy. We will make some updates in JavaScript files, sites.js, in index. We will create Okay, new controller. So the difference between a normal web application is that we have in the top here, as you can see, a new project that is a Service Fabric project. This project, and in the startup, we need to inherit from stateful service to be able to run it as Service Fabric. So here you will find this link in the end of this presentation if you want to try to copy the content and to try your application. So as I said here, so we try to make some changes in sites, index, in the layout to change some things, and we'll create a new controller after. Here I will just paste the contents. After, the same for index. Index, it's okay. Now we go to the layout to be simplified more, just because we don't need all of this. Just it's an application about voting, so we have some button to add to delete vote, some vote, and to display that in green or in red, like counter of vote. It's easy, simple. Here, I will just show you here in the startup, we need to add this to inherit it here. So I made some changes in this one just to be able to get the right output. Okay, I want just to change the name to be significant. I've made some changes here, add some block that I needed after execution, as I said. Now we'll go to add the new controller. Okay, here I have to add a system HTTP. System web HTTP. Okay, now new controller. We give a name. No, it's empty one. I don't need to include anything. Voting controller. And I will just copy the content from Microsoft documentation, simple. And after we will launch this application. But before launching this application, I will show you after how we can just clone this sample to try Service Fabric. Here, just open. Okay, I'll try to use some tools in Visual Studio to clean my usings. New tools added in the new version of Visual Studio. Here, as you can see, on one operation that we did everything. We'll add and we'll delete the vote. Now, I will show you how we just clone this application. Don't need to copy and paste the contents to test it. We change just this name to be more significant. Voting web, for example. Now, we compile to be able to be sure that everything is okay. No missing using or no block added, no errors. Here you can find the link in the end of this presentation. So just we copy this and we will clone this one. We close the solution after clone and check, which was GitHub. As you can see, clone. We have clone. We will wait that the all content will be loaded. After we will go to voting SLM solution to load the application. Still loading. So this application will include two parts, the web part and the data part. This one. And we have the service fabric in the top, sorry. We try to load, to rebuild. We start our application and we check in our Service Fabric Explorer if we have some problems, if it's okay, if we have errors. It's green, it's red. Here it seems working. Now, just to verify, to be sure that it's okay, here, as you can see, two applications. We have the previous one and the new one. The new one includes two projects. Here you can see our projects, that data and the web part. So, here we get some problems, communication, as you can see. So this dashboard can show us which problems. So just we reload. This is just to show you how we can use it. And we have another beta, another one, Explorer. You can use it to test too, or you wait for this one. So here, as you can see, I have some errors. Now, what we did here, to verify, we need to verify if we still have this application, we still have problems. And as you can see, when we end compiling, the application will disappear from. So we need to publish it to be able to have it always. Now we will go to see our application. So I will choose the pool here, 80. Let's see the content of our application. The web part. This is the data part. We have the status. Now it's okay. No error. It's loading. And here our sample. So we will add vote, for example, 1. I click on add. I get remove. We have 3. Can add another 1. 2, for example. So it's working. Backend and web parts working. So it's green. Now we will build .NET Server Fabric. We deploy it. We try to deploy it here. We click on Publish. Okay, as you can see here, we will publish to the cloud, to the Azure. Let's start here. We need to define all required information to the subscription, to the name. All tabs should be checked, should be filled, as you can see here. If you click Create, we get some pop-ups, red one, to say that I need to fill all tabs. Okay, I keep filling, so I need to fill all this information related to virtual machine, to password, to certification. And advanced, don't forget to add the port 8080, so we are able to go after to the application. So we'll click now on create after. Deploying, publishing and deploying a cluster in Azure may take few minutes. So choose, it depends from many things, from the machine, characteristic of the machine. It's recommended to create a separate resource group, so you are able after the test to delete only resource groups, so all research related will be deleted. Now I will just verify I will compile just to see here. It's okay, I think. I will click on publish. Maybe I will try to check again, because we need few minutes to be ready before publishing. So here, after a few minutes, I will check my cluster if it's created or not. So if it's not created, it will be red because some things are missing. Here, I will check in Azure. I will search for my resource group. Here, it's easy to find your service fabric by resource group. And as you can see here, it's okay, it's created. So now I will click on publish again. Okay, publish. Here all properties. Here we have here my resource group. It's okay. It's ready. It's updated now, so I can publish now. I have the link, as you can see here. The link is it's not a simple text now. It's a link. It's a real link. So I'm ready to do that. So you need to check that to not get any problems in publishing. So I click on publish. Here, everything is published. I will go to check Azure. Start by Service Fabric Explorer to see my application. It's normal because I don't have a certification. I didn't require any certification, but you need to add in production certification before. So here I have 5 nodes and my application already deployed. Now I will check the link of the application. here. I will add the link, and this is my simple boat one, delete, and everything here. It's okay. So it seems working. And my application is published in Azure Service Fabric. Now we will execute Docker container in Service Fabric. You need to have Docker container desktop. So if we talk more about Docker, what's Docker? It's a tool that makes it easy to create, deploy, and run applications by using a containerized approach. These containers are lightweight and take less time to start than traditional servers. These containers also increase performance and lower cost while offering proper resource management. Another benefit to use Docker is that you no longer need to pre-allocate RAM to each container. And one of the benefits of container that when you have application, you can just deploy it on premises, lift and shift, simple lift and shift, and you have more options, refactoring, rehost, or re-architecting. Now we build and execute Docker container in Service Fabric. So the same template, create a new project Fabric, and this time we choose container. What we need here is that we have to deploy before an image. If you don't have an image already, you can use Microsoft image. So I have an image, so I will just copy the link from Docker Hub, for example, here. Now container, I will give a name, as usual, and I will copy from Docker Hub one of my deployed application on Docker Hub locally. So I need to have Docker Enterprise Desktop started loading because I will get my image locally, not online. But you can use an online image. So I will copy that. I need to give my username. If you get .NET Core image from Microsoft, you don't need to add your username because it's open and online. Now we load it here, as you can see. Here we have our application. So in configuration, you can find the image, the link of our image. We just compile, and we can do the same as .NET Core application. We did the same publishing. So here we go to Stateless Services. Today we just tried some stateless services, but we have stateful services. Maybe in another session we can give an example to explain more about stateful, but what you need to get today is that stateless services, we don't have any state to maintain, and for stateful services, the state is stored with the service, so it's more, let's say, it's better choice if we have many database. If every services will use one database, it's better to use stateful services. Because the state is stored with the service, so allow for state to be persisted without the need for an external database, and data is located with the code that is running the service. So here we conclude. Today we see an overview about microservices, not detailed, but just to focus on the importance of using microservices. We present the Service Fabric, its architecture, and we try to prepare our demo. the environments. We created a new local service fabric. We created a service fabric using Studio, .NET Core. We tried to publish in Azure Service Fabric. And about monitoring and diagnostics, we, as in Service Fabric Explorer, we saw that we can check the health of our application, if you have any error or not. We can, if we are in Azure, we can use Azure Monitor tool to get more statistics in monitors, more diagnostics. It's more easy. So I hope that we covered at least, we get an overview, let's say, about Service Fabric, and we understand the importance of using these technologies. Here, many references, I recommend them. You can find the essential about Azure Service Fabric. It's in French, but I like this presentation really. I recommend it. And we have all links that we used during our session. Thank you. If you have any questions, please use the chat, or you can, as I said, you can follow me on Twitter, send me the questions, or by email. Thank you so much. Have a nice day.